How you doing guys? Bioinformatics guy here with the last video of the series Python for Bioinformatics. In this video we will be talking about how we can handle exceptions in Python. Now in Bioinformatics you will have like very complex files and there will be a lot of files, also be huge in size, and you have to like process them. In the middle of the processing it is possible that there could be some very peculiar things in the file and that can cause error. And if you don't have exception handling incorporated in your code, then that function will stop right over there and you will not get the result. Like handling the large files can take a lot of time, so after like 1 hour of code running, at the end of the day you will be ending up with nothing. So what we do is we add exceptional handling statements which will do the things accordingly so that our whole program don't crash, and at the end of the day we end up with something. Moreover, in bioinformatics you will be using different APIs, and APIs give you some sort of error. So in order to handle that situation you will also be using exceptional handling statements. So let's start coding. Let's start right away from the very basic form of the statements that handle the exception. So the idea is that it's like if else, but it's a bit different. So rather than using if, we use try keyword, and then here we will add try statements. Okay, and then if it is unable to execute those try statements, then we will use this keyword except. And then here we will be adding the error class. I will talk about the error class in a moment. So right now I'm just gonna write ERRORCLASS. Error class, let me give you a little info, but what this could be. There could be type errors, then there could be value errors, then could be name errors. We will talk about them one by one in detail after a few minutes. So, and after this you will be adding your except statements. Like you will try to do something, you will try to read the file, and if you are able to read the file properly, like you are able to process the whole file, then it's good to go. Otherwise, if in case of getting an error, you will come here and then you will execute some stuff over here where my cursor is right now. So here we will add except statements. Alright, so that's pretty much it about the basic idea. Let me show you examples of different error classes. So first of all, we will be talking about one of the error classes. Now I will write a piece of small code, and then what you have to do is to pause the video and try to guess what kind of error we will get in the comments down below. Okay, so I'm gonna write print, and then I will be printing x plus 2. Okay, so now you have to tell me that what will be the error that we will be getting, and you can write down that in the comment. Okay, so I guess you have done that, so let's run this and see what we get. So you can see that we get the type error. This is usually mentioned in the very last line of the error that you will see. Now let me explain why we get the type error. We get the type error because x is a string over here and we cannot add a int into a string. So that's why we get the type error. Only concatenate string, not int, right? So it basically explains itself. Let me give you another example. So now we will be printing again, and this time we will print x, and you have to guess what error we will get this time. Okay, I'm assuming that you have guessed it so I will run this and see. So this time we get name error. So name error happens when you are trying to use the name of a variable, however you haven't defined that variable so far. So in the Python environment that variable does not exist, but you try to use that, so then you will get the name error. This one is going to be really important, especially for handling Python files. So we will be using the open function, and then I'm gonna give it a name of the file which does not exist. So let's say that seek dot FASTA, we will add extra a so that we're sure that this file not exists. So let me run this. If I run this, I get this error, file not found. So this is very self-explanatory that the file is not found and no such file in the directory. Okay, so we are done with talking about the errors. So let's take a look at how we handle these things by using except statements. Okay, so we are going to be defining a function in which we will get the GIDs from a FASTA file. You know what the GIDs are. I've talked about it extensively in the previous videos. So we will start with def and then we will name our function get GIDs, and then we will simply give it a file name. Okay, and then we will use the try statement here. We will do try and with open file name as file return. Now we are going to use list comprehension of here, so we will extract GID and we will give it line for line in file if line 0 is starting with the greater than sign, because the lines which start with the greater than sign usually contains the GID. This is like basic FASTA format. I hope you are familiar with it at this point. Otherwise you can go back to my previous videos. I have explained it. So here we will add the except statement. So if the program fails to run this and if the program fails to find the file, then we will come here in the except statement, and also we have to add the error class over here. And if the program fails to find the error, which error class we will be having? File not found error. Okay, so we will write file not found. Oh no, so file not found, and then we can print something over here, and we can simply print file then we can say file name not found or not readable. All right, so and then here is very important thing. Usually when a function fails to do something and it ends up in error, it usually returns you none. So now if we don't write a return statement over here, automatically this function, when it ends up in an error, it will return none. Now the problem with that is when you are using this function to read multiple files and then at the end you are concatenating all the results, if at some point your function returns none, whole main result, and at the end of the day you will be ending up with nothing, like I talked about earlier. So it will be returning none, then the next function will get into an error, and so on and so forth. So as we know that we are going to concatenate our results, so rather than returning none, we will return an empty list, so that if one file is not readable, then it will give an empty list, and this empty list will be concatenated with the other files which were readable. So that's pretty much it for this function. Now there is a very small problem. You can see this yellow line here, and this is say that this is not defined. So we know that we have defined this function previously, so we will import this. So we will be writing from Python for BINF import, and we will write extract GID. So as soon as I write this line, you see that this yellow line goes away. So we will say get GID, and now we will give it a file name which does not exist, like seek.fasta, like this. I mean, a stupid name. Okay, and you see that rather than getting an error at this point, we are returned this empty list. So if we loop over this function in another function, then we will not get the error and program will still be finished with some results. So that is really cool, and let's run this with a reasonable file name. We have this longest seek.fasta, so we can use this file longest seek.fasta. okay, so it's also suggesting that this file exists. So if we run this code now, we will get all the GIDs in that function. So before we end this video here, I would like to tell you that I will be adding a table of all the possible error classes on my website. You can find the link of that in the description of this video. So that's pretty much it for this video and for this whole series. I hope you have enjoyed and you have learned a lot from this series. Stay tuned, keep subscribed. I will be starting a new series which is going to be really helpful for your bioinformatics career and which is going to take you to next level.